Hey, Bogdan Vrisky here. We make algebra easy just for you. In this video, the difference of squares explained. So let's dive into this beautiful video. So before we start with an example, I want to tell you that again, in mathematics, the first thing you want to recognize pattern so that you can utilize strategy that you learning from each videos that I'm sharing with you. So once you recognize the formula that this is difference of squares, you express in factored form, and then you're checking your work in the end. So that seems simple, but every time we say things are simple, sometimes your mind tends to complicate. So without further ado, work with the formula first. So consider the following product: a plus b times a minus b. So you multiply two binomials together, and obviously by now you know how to multiply binomials. So a times negative b times a, and b times negative b. So right here you have a beautiful expansion. Then you simplify each product, and finally you add like terms. So negative AB and positive AB, because BA, if you understand the rules, so this is the same as AB. So negative AB and positive AB cancel each other out. There you go. So this is the difference of squares because we have exponents involved. So this is the formula, the difference of squares that we will be using in the examples down below. Before we go to the examples that involves variables and numbers, let's work with numbers first to warm up our thinking. So 4 squared minus 3 squared represents a perfect example of difference of squares. So you can use the formula and express it as a sum, 4 plus 3 multiplied by the difference, 4 minus 3, and you test it. You verify this. So 4 squared is 16, 3 squared is 9. So essentially this is 16 minus 9, and whatever that is must be equal to the right side. So 4 plus 3 is 7 times 4 minus 3 is 1. So indeed you can say left side is equal to the right side. Bingo. Okay, so let's start with one example which is simple. So x squared minus 9, how is the difference of squares? Because you have x squared, and then by using rules of exponents, or if you recognize this 9 is a perfect square number, so you can express it differently as 3 squared. So you have a difference of squares, terms raised to exponent 2. So quick application of the formula. This is product of the sum and the difference of those two terms. You can check your work, and you should. That's sort of the strategy that you want to learn. X times x, 3 times x, x times negative 3, and 3 times negative 3. So you have to be able to list 4 because you multiply 2 by 2 terms. And when you simplify it, so the middle terms, negative 3x and positive 3x, are canceling each other out. So you have x squared minus 9. Beautiful thing. You have verified the solution. Another example, a little bit more complicated, but still nice. So 4x squared minus 25y squared. So the variables are to the power of 2, x and y, as you can see. And how is this a difference of square? Because you can recall rules of exponents. So 4 is a perfect square number, so this is 2. And 25 is a perfect squared number, which is 5 squared. So when you square the product 2 times x, this is essentially 4x squared, right? And when you would square 5y, you can clearly see that this is 25y squared. So hopefully that makes sense. And now quick sort of application of the formula sum 2x plus 5y times 2x minus 5y, and you're done. Check your work again. You would have to multiply it together, carefully combine like terms, and in the process you see that you have 2 by 2, which is 4 terms in total, and the middle group 10xy and negative 10xy cancel each other out. Therefore, back to original question, everything is good. Bingo. All right, so more examples. One more complicated example which you may find on your tests or quizzes or even final exam. So please follow along with me. So this is a binomial squared, which is another entity in itself, and we talk about perfect trinomials in another video, how to factor it, etc. But in this particular example, we have x plus 3 squared minus 9y squared. So pattern recognition. This is a term which is squared, and you subtract from it another term which is squared as well, because 9 is a perfect square number. So this is 3y, in other words, and expressed as with exponent 2. So quick application of the formula. So add terms inside a bracket, so as if you were adding a plus b. So there you go. Sum multiplied by the difference. And now you have 3 terms inside of each bracket, which is okay. There's nothing wrong with that. Absolutely. Your goal is to be collecting any like terms when applicable and simplify this expression. Since x, 3 and negative 3 or positive 3 are not like terms, therefore you can't add them together, so you leave it. You leave it like so, and you're happy. You're done. Hey, checking your work, it's the step that we can't omit. So when you choose to multiply this 3 by 3, you will get 9 terms in total, because each time you multiply by 3, you create a group of 3. So you follow the pattern, and then you don't care how many you have in each bracket, because you understand that you must connect each term from first with every single term from the second. So in total, you can test me by working together that you see 9 terms. Long process, but I want you to do it. Do it on paper. You know that you can have ability to pause this video and start doing it by yourself. So please do it and start collecting like terms. 3xy, positive and negative, cancel each other out. That reduces the complexity. Then 3x and 3x is another term that you add together. So you have it right here. 9 is a number by itself, so you could have kept it at the end, but I didn't, and I will explain why. So that we have from 9, we have reduced into 4 because of the simplifying process. And we created a perfect square trinomial minus 9y squared, which is equivalent or exactly the same what you had in this question. So you're good. You can say, I'm almost there, but what is all about this trinomial? X squared plus 6x plus 9 is a perfect square trinomial, so you can convert it into that binomial squared. And there are other video where we factor perfect square trinomials. So if you're not familiar with that technique, so go and watch the other video as well. Don't forget. So this is perfect spot because it tells us that we have exactly original questions that we started in this example. Therefore, everything works perfectly. So And now I'm going to share with you sort of a secret weapon, if you will, because this difference of two terms can be utilized uh, as a difference of squares if you're familiar with radicals at this point. If not, forget about it, and later and in the next math course you will come back and review it. But for now, if you show that x minus 3 is equal to square root x squared minus square root 3 squared, then we have a perfect difference of squares application. And this question oftentimes appears in your calculus course when you have to simplify limits. So it is very good to know that difference of squares formula from previous math courses. So if you just follow the rule, this is the sum multiplied by the difference of those two terms. Bingo, you have nicely factored x minus 3. Similarly, you have a situation when one term is squared, the other is not. So a squared minus 2. So this is why you say a plus square root 2 times a minus square root 2. That's the difference of squares. If you expand it, you guarantee to get the original question. Test it by yourself. And finally, this beautiful example where you have almost the same thing repeated twice, but it is not. But this nicely yields to a single term statement when you express it in factored form and then you simplify. So a plus b squared minus a minus b squared represents a difference of squares, right? So when you apply the formula, you go first plus the second term added, so a plus b plus a minus b, and then the difference, a plus b add a minus b, or subtract a minus b in brackets, but you have to subtract a minus b thinking of this as a solid unit. So when you distribute the negative sign, you get negative a, and negative minus b becomes positive b. So this is the difficult step in this example, but it's a beautiful example because after all, when you start collecting like terms, you have just reduced this long expression into 2a, and the second set of brackets, when you see that a is gone, you have 2b's. And when you multiply 2a times 2b's, you have 4ab. So this is an expression that got simplified from big complex sort of starting point into very simple form. So hopefully that video was helpful. Like it, share it with your friends. But before you go, don't forget to do the practice questions. After all, you have to implement your knowledge by practicing. So we'll see you next time. Bye for now.